All right, now comes the fun part. We are going to add and subtract fractions. And adding and subtracting with fractions ends up, and you'll find out throughout the course, when we're adding and subtracting, it gets really picky. So we've already shown I can multiply, I can divide, I can do all that kind of good stuff. Well, when we're adding and subtracting, I've got to make the fractions talk to each other. So I need to get what's called a common denominator. And once I have that denominator, then I can do my addition and subtraction. And so finding the common denominator is going to utilize what we did before, which is way back in here. I don't even know where it went. Doesn't really matter. All right, it's back in here where a number divided by itself is 1, and 1 times the number is itself. So I'm kind of going to be making things worse. I'm going to be taking a fraction that might already be simplified, and I'm going to be making it look uglier. And that's all going to be in the name of getting a common denominator. So first of all, let's just do a basic one where we've already got a common denominator. So I've got 10/17 plus 4/17. So when I read this, I can actually read it a little bit more simplistic, and I can say I have 10 of these 17ths, and I have 4 more of these 17ths. How many 17ths do I have? So in that case, it makes a little bit more sense. You don't want to combine your denominator. Your denominator literally stands for denomination. So if you think about money, you have 1s and 5s and 10s and 20s and that kind of thing. And then you can count how many of each of those you have. So your denominator tells you the language that your fraction is speaking. So in this case, I'm talking about 17ths. So if I have 10/17 plus 4/17, how many 17ths do I have? I have 14/17. So do not fall into the trap where you would add that 17 to itself and get 34. Do not do that. So once I have my common denominator, this one was easy. It already started off that way. I add my numerators together, and then I figure out where to go from there. Can I simplify? Well, this one is already simplified. I can't break down 14 and 17 to where they're friendly with each other. And I can't change it into a mixed number or anything like that. Something else that you will find out is the higher up we get in math, the less we like mixed numbers. So I do not really like mixed numbers unless I'm baking cookies. So let's try another one. We have 5/18. So 5/18 plus 3/18. And I would like to add those together. So at this point, can I add them? Can they talk to each other? This is talking about 18ths, and this is talking about 18ths. So yes, I can add them together. So if I have 5/18 plus 3 more 18ths, how many 18ths do I have? I have 8/18. So the addition part is done, but now hopefully you'll notice I can break down the 8 and the 18. They're both even, which means they're divisible by 2. So this can be 2 times 4, and this can be 2 times 9. And so any number divided by itself is 1, which means my simplified answer is 4/9. Okay, so it's okay because it's an equivalent fraction. I just divided out something that represented a 1. So let's go a little bit scarier. I've got 9/25 and 1/5, and I'm going to add those together. So now my fractions can't talk to each other. So what I'm looking for is a least common multiple, which is another way of saying common denominator. I want the smallest number that 5 and 25 will both go into. So a little trick that I have is I look at the larger denominator and I take multiples of it. Okay, so I'm going to take 25. Does 5 go into 25? Yes, it does. So 25 is my common denominator. Okay, he's already got it, so he's going to stay this way. This one needs the 25. So how do I make a 5 into a 25? I multiply by 5. So notice I am multiplying by 5 on the top and the bottom. So what is 5 divided by 5? It's 1. So I'm really just multiplying by 1. 1 times anything is itself. I'm changing what it looks like. I'm not changing what it is. And I'm just making it in a situation where it can now talk to each other. So I have 5 over 25. And now I'm working with something that they're both in 25ths. So these two things can talk to each other now. So if I have 9 of the 25ths plus 5 of the 25ths, that means I have 14 of the 25ths. And so this is not reducible, so it's done. I am all done. All right, so let's try one where we've got to change both. If I have 7/8 plus 7/12, first of all, this is kind of a trick because the numerators are the same. I don't care. I want my denominators to be the same. Okay, and right now this is in eighths and this is in 12ths. So here's my little trick. Take your larger denominator and take multiples of it. So does 8 go into 12? No. Well, then let's try 12 times 2. 12 times 2 is 24. Does 8 go into 24? Yes, it does. So 12 goes into 24 and 8 goes into 24. So what I'm going to do is change both of these fractions to have denominators of 24. So let's just look at the first one first. How do I change an 8 into a 24? I multiply by 3. So I'm going to multiply by 3 on top and bottom. And that's going to allow me to get my 24, but I'm not changing what 7/8 is. I'm just changing what it looks like. So that gives me a 21 on top and a 24 on bottom. What about this one? What do I multiply by 12 to get a 24? I multiply by 2 on top and bottom. So remember, 2 divided by 2 is just 1. I'm changing what it looks like. I'm not changing what it is. So this is 7 times 2 gives me 14. So now I've got 24ths involved. So 21 24ths plus 14 24ths is how many 24ths? Well, I've got 35 24ths. Okay. So now here's your option. This does not reduce. And like I said a while ago, the higher up we get in math, the less I really want to deal with mixed numbers. I would leave it like this. But for practice, let's go ahead and practice getting a mixed number. So I'm going to take 24 into 35. How many times does 24 go into 35? It goes in once. And then I'm going to subtract and get 11. So this is the same thing as 1 and 11 24ths. Okay, so there's my 1, my remainder over what I divided by. So again, it depends on how the question is being asked. But for the most part, the higher up you get in math, I don't ever want to see mixed numbers again. But we're kind of getting you out of there right now and getting you into proper fractions and improper fractions. So I've got 2 and 2/6 plus 1 and 2/3. And now it may be a little bit of a waste of time, but I would like to go ahead and I'm going to do this problem 3 different ways. Okay. But what I'm going to do is I'm going to change it into an improper fraction. And that'll just make life a little bit easier. If I've got improper fractions, I know how to work with those. So that's what I'm going to do right now. So that's going to be way number 1 that I work this. So I'm going to multiply and then add. So 6 times 2 plus 2 gives me 14/6 plus 3 times 1 plus 2 gives me 5/3. Okay, now if you'll notice, 14/6 reduced to 1/3. Okay, so you'll still get the same answer. but I can either change this to a denominator of 6, or I can reduce this by 2. So if I divide the top and the bottom by 2, I will get 7/3 plus 5/3 gives me 12/3. Well, that reduces. What is 12/3? 12/3 or 12 divided by 3 is 4. So that's way number 1. Way number 2 is I could have looked at this and seen that 2/6, and this is just something that comes with practice. Okay, 2/6 reduces to 1/3. Divide the top by 2 and the bottom by 2. So 2 1/3 plus 1 2/3. Now I can add the big numbers together. So 2 plus 1 is 3. And then 1/3 plus 2/3 is 3/3. Well, 3/3 is 1. So 3 plus 1 is 4. Okay, and I said 3 ways. I'm not going to do 3 ways. The other way, I didn't realize it was going to be a nice friendly number. So you can approach these different ways. So as a general rule, because I deal with mixed numbers so infrequently, I will almost always change them into mixed numbers. I'm sorry, I will almost always change my mixed numbers into improper fractions and go from there. Just because it's easier, because that's what I do all day long. So now let's try another one. I have 9/11ths, and we're going to go into subtraction, minus 5/11ths. So my question is, can my fractions talk to each other? Yes. I have 9/11ths, and I'm going to take away 5 of those 11ths. How many 11ths do I have left? I have 4 11ths left. Okay, so subtraction is going to work the same way. Let's try another one. I've got 7/6 minus 1/2. So I'm going to have to get a common denominator. So I do know that 2 goes into 6. So my common denominator is going to be 6. So 7/6 is going to stay the same. And now, how do I get a 6 on the denominator? I multiply top and bottom by 3. So that gives me a 3 on top. So 7/6 minus 3/6 is 4/6. And now we just see, can we reduce? And we can. I can divide the top by 2. I can divide the bottom by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So that gives me 2/3. That's the same thing as if I were to say 2 times 2 and 2 times 3. So my 2's reduce out and leave me with 2/3. Okay? So let's try another one. I've got a 13/15 minus 4/9. Okay, and this one is going to take me a little bit of time because I've got to figure out what my common denominator is going to be. Because 9 doesn't go into 15, so I've got to change both. So I'm going to take multiples of 15. Does 9 go into 15? No. What is 15 times 2? It's 30. Does 9 go into 30? No. Okay, 15 times 3 is 45. Does 9 go into 45? Yes, it does. So my common denominator is 45, and now I just got to figure out how to get from one to the other. And I'm going to finish this video because we're almost done, so it's going to be a little bit longer. I usually try and keep them to about 15 minutes. So this one, how do I get from a 15 to a 45? I multiply by 3. So my numerator becomes 39. How do I get from 9 to 45? I multiply by 5. So that gives me a numerator of 20. And 39 of these 45ths minus 20 of the 45ths leaves me with 19 of the 45ths, and that does not reduce. Okay, so let's try another one. We have 9 7/8 minus 7 1/3. So what did I say a while ago? When I'm dealing with mixed numbers, I usually go straight into improper fractions. To me, it just makes it easier. So I'm going to do 8 times 9 plus 7. So 72 plus 7 is 79/8 minus 3 times 7 plus 1 is 22/3. thirds. So now I need my common denominator. Okay, my common denominator is, well, 3 doesn't go into 8. Does 3 go into 16? No. Does 3 go into 24? So I did 8 times 1, 8 times 2, 8 times 3. It does go into 24. So 24 is my common denominator. And you may have a way that you prefer to do this. I don't care, as long as you get the right answer. So I just, as a general rule, prefer to go to improper fractions. So how do I move from an 8 to a 24? I multiply times 3. How do I move from a 3 to a 24? I multiply times 8. So 79 times 3 is going to give me 237. 22 times 8 is going to give me 176. So now my fractions can talk to each other. So 237 of the 24ths minus 176 of the 24ths will give me 237 minus 176 gives me 61 of the 24ths. Now here's the deal. We normally, if we start off in mixed number world, you better end in mixed number world. Okay? So I'm going to go ahead and change this back into a mixed number. So how many times does 24 go into 61? I know it goes in twice, so that gives me 48. So 61 minus 48 gives me 13. So my answer is 2 and 13 24ths. 2 and 13 24ths. So you could leave it like this, or you could put it back in mixed numbers. Okay, let's try another one. I've got 10 minus 7 and 3/5. So this is 10 over 1. I'm going to go ahead and change this into an improper fraction. Again, if you watch the other videos by the publisher, or if you do search on Google or whatever, it may tell you a different way to do it. I'm just telling you something that you can bank on every time. Okay, so I'm going to change this. So 5 times 7 plus 3 is going to give me 38. So I've got 10 over 1 minus 38 fifths. Okay, so my common denominator is going to be a 5. So he's already at a 5. This one needs to be multiplied by 5 on top and bottom. So I'm changing what it looks like, not what it is. So I get 50 over 5. And now 50 minus 38 gives me 12 fifths. Okay, 50 minus 38 gives me 12 of the fifths. So I can either leave it like this, or since I started off with mixed numbers, I might need to change it back to a mixed number. So 5 goes into 12 twice with 2 left over. So that would change into 2 and 2/5. Okay, and then let's do one more like that. So I've got 16 minus 4/7. Okay, so that's a 16 over a 1. My common denominator is going to be 7ths. So I need to multiply the top and the bottom by 7. So 16 times 7 is going to be 112 over 7. So 112 sevenths minus 4 sevenths must be 108 sevenths. And 108 divided by 7 does not reduce pretty. Okay, so you can either leave it as 108 over 7, or we can change it to a mixed number. So 7 goes into 108. That's a 5, so that gives me 35. And so I end up with 15 and 3/7. So either way. And honestly, if you're used to it, you could just do this in your head. If I've got 16 and I take away a tiny little bit that's less than 1, that means I've got more than 15. So 15 would, and then I'm 3/7 away. I don't know if that makes sense to you. So I would have done the last couple in my head, just kind of by counting up. So I would be in the 15 and I'd be 3/7 shy of 16. So 15 and 3/7. Anyway, you can always bank on improper fractions.